Hello everyone, in this video tutorial I will be taking you through BMAC, where B stands for Berkeley. So this medium access control protocol was invented at Berkeley University, so that is why it's named as BMAC. So wherein it's quite different from that of SMAC, that is Sleep Mac, because here no such frame is used, that is no schedule is used. So whereas in SMAC we were using a fixed schedule of duty cycle, that which had both the listen interval as well as sleep interval, but whereas here we don't have such facility. Instead of that, here we will be eliminating the drawbacks of SMAC. That is, the very first point over here is energy consumption is the main performance metric. Energy consumption is the main performance metric. Preamble sampling mechanism and BMAC protocol to overcome disadvantages of SMAC. So here we'll be using something called as preamble sampling, and we'll see how exactly this preamble is sampled and how exactly it facilitates communication between nodes. Duty cycle operation requires sleep wake up schedules. So that's the drawback of SMAC, so that which was using duty cycle operation. So, and in order to accomplish this sleep wake up schedule, sync packets were used in SMAC in each frame. And the other disadvantage, major disadvantage of SMAC was that all nodes need to be active during listening period in order to assess if at all there is any thing happening in the carrier. So whereas in BMAC, it provides a core MAC protocol. So here it can be thought of as core MAC protocol, because using this BMAC, there are a lot of other protocols which are designed, higher level protocols which are designed. So thereby, the very first point over here is BMAC provides a core MAC protocol that is simple and reconfigurable. So basically this is very simple because it makes use of only preamble sampling, and as well as it's reconfigurable because there are a lot of options which can be toggled, and we'll be going through that in a short while. So it's a simple and reconfigurable by higher level protocols. So it also has an optional link level acknowledgement mechanism. This provides so here optional link level acknowledgement mechanism is provided without any RTS and CTS handshaking signals. So because in SMAC RTS and CTS messages were sent prior to the data transfer, but whereas here this is optional. Acknowledgement is optional in this BMAC, and this can be made visible without any of these handshaking signals. Simple implementation results in small code space. So basically this BMAC is very simple and reconfigurable. There are a lot of options which can be turned off. So thereby this ultimately results in small code space. And hence this is mainly used in TinyMac OS. So here BMAC makes use of two mechanisms. The very first mechanism is sleep wake up schedule using low power listening. So whereas in SMAC we had adaptive listening as well as periodic listening, but here we have the concept of low power listening. And the second mechanism is carrier sensing using clear channel assessment, abbreviated as CCA. But whereas there, in order to sense the channel, all the nodes were supposed to be wake up, and that was accomplished by using synchronization packet. So here it mainly depends upon LPL and CCA, and we'll be going through these two concepts in detail. So BMAC has implemented on TinyOS and enables rapid development of cross-layer solutions. Higher layer protocols can toggle the CCA and acknowledgement, so this thing can be turned off, similar to that of this acknowledgement mechanism. and we can also set the back off parameters on a per packet basis. So this back off parameter can be changed according to the kind of packet being transmitted. And the third point is change of LPL. Change the LPL, that is low power listening can be altered here. So this is the diagram that which shows how exactly preamble sampling is done. So here basically this shaded region is the point where a node is actually listening. So this is very minimal when compared to that of sleep cycle. So sleep can be thought of as occupying 80%, and whereas awake is just 20%. So this you can see that here A is awake, here B is awake, and here C is awake, and these are not aligned, meaning each and every other node has its own schedule and it need not to all be in sync. So here there is one more important parameter called as TP, and this TP is called as sleep schedule frame length. So this sleep schedule frame length is given as TP, and we'll be going through that all of that in detail. So here is a frame. Now the thing is, if any node is having message, first what it does is it starts to transmit long preamble, and this long preamble is sent to the intended node point. So here in this case, because A is having already having data, it starts to transmit this preamble, but this preamble contains no data in it. It is just used to wake up the other node. So here, because the packet is intended for node B, when node B jumps from sleep state to, and when it starts to listen, and when it's awake, it will start to listen the A. But the thing is, it has to keep on listening onto this A till the preamble finishes, because you can see that this A could have stopped its preamble just here itself when B was awake, but because preamble is always of fixed length, so here this node B continues to listen to this A for a longer duration, and only when preamble is over it will start to transmit it data, and this data, when it gets successfully transmitted, this B confirms it through acknowledgement back to A. And whereas here node C, even though it was also awake during the preamble timing, but the thing is, this preamble will be sent will be containing an important information regarding the destination node. So C also goes through that preamble, but when it gets to know that it's not the intended receiver, so it continues to go to sleep. So this diagram can be remembered by using this short form: sleep preamble followed by data, wherein this bar indicates that this data block has to be included within this, and whereas here for node B it's SLA, sleep listen followed by, within listen we have this acknowledgement, so because of which this whole bar on the top of L and A followed by sleep. So this is preamble sampling, and we'll be going through that in detail later. So low power listening, so this is basically can be thought of as low power listening. So drawbacks of fixed duty cycle operation of SMAC and its derivatives can be addressed by removing the requirement of schedule. So here there is no schedule associated with any of the nodes. All the nodes need not have to wake up and sleep at the same time. So as you can see, there are different nodes waking up at different instant of time. So here they need not wake up at same time. Each node can determine its own sleep and wake up schedule without any synchronization. Transmitters, to synchronize with their intended users, they'll make use of preamble sampling, low power listening. So here this preamble will be sampled. Main idea behind low power listening is to send a preamble before each packet to wake up the intended user. So before we transmit data, so this preamble is a must in Berkeley MAC. So accordingly, each node periodically wakes up, turns its radio and checks for activity on the channel. During this small period, if activity is detected on the channel, the node stays in the receive mode. So if at all if there is any activity when it wakes up, so activity is here preamble, so then the node will enter into listen mode, or else it continues to be in sleep. So here is an example where three nodes are used: node A, node B and the neighbor node C. So where node A is the transmitter, node B is the intended receiver. The sleep schedule frame length is determined by this TP. At each TP seconds, the node wakes up for a short amount of time. So for every TP, this node will wake up. Any node you take will wake up for a very short interval of time to detect the activity on the channel. Wake up time of each node is not synchronized with the other nodes. When node A has a packet to send to B, it first sends a preamble of length TP to wake up the node. So this preamble is also of length TP and it's constant. When node B wakes up, it listens until the end of the preamble. So it bees in this listen mode till this entire preamble ends, and only then it can get the data from node A. It listens to the end of the preamble and determines that the packet is destined for itself and does not switch to sleep state. Node A then sends data packet to node B, replaced with an acknowledgement packet if transmission is successful. Node C also wakes up during the preamble transmission. However, since the packet is not destined for itself, it switches back to sleep state. So this LPL, that is low power listening mechanism, removes the need to send periodic sync messages to form virtual clusters. But at the trade-off is between at the cost of transmitting long preamble. So this is always fixed. So thereby, that's the trade-off that which we are paying instead of sync message. Instead of sync message, here we are having long preambles before each data transfer. Energy, so thereby energy consuming per packet transfer, LPL, is greater than that of sleep wake up schedule based protocols, that is SMAC. Whereas energy efficient for duration with no traffic. So when we speak with respect to energy efficient, BMAC is superior, but with respect to energy consuming per packet, so this is not so good compared to that of SMAC. The traffic pattern defines the optimal listen interval TP. If the listen interval is too small, if this TP is too small, then each and every other nodes has to keep on waking up. So the nodes waste energy by frequently waking up. On the other hand, if the listen interval is too large, energy is wasted on transmissions since long preambles need to be transmitted before each communication attempt. So that was about low power listening, LPL. Then we have this clear channel assessment. So for this clear channel assessment, the main motivation was in a wireless channel the ambient noise depends upon the environment. So according to different environments will have different ambient noises, and thereby the received signal strength varies and it keeps on fluctuating. Packet reception exhibits a fairly constant channel energy. So successful transmission of packet is always associated with this constant channel energy, and we can conclude by this we can conclude that to accurately detect activity in a channel, several channel measurements should be taken over time. So because of this noise and all, so we got to accurately detect activity in the channel, for which there are several measurements. The main goal of this clear channel assessment is to differentiate between noise and a signal to accurately assess the channel activity. This is addressed through software approach to estimate the noise floor before any decision. So first we would like to estimate this noise floor, only then we can continue with this CCA. So basically it has two phases. In order to continue with CCA, the very first step is to noise floor estimation. During this, the noise floor estimation is performed using FIFO, that is first in first out Q, followed by signal detection. So CCA has two steps: noise floor estimation and signal detection. BMAC does not assume a fixed noise floor for CCA. Signal strength samples are taken during times when the channel is assumed to be idle. Noise floor calculation involves medium ST and a parameter A, which controls the effect of the delay. So it has both median as well as delay in it. So ultimately this noise floor calculation AT is equal to AST plus 1 minus A ST minus 1. So in CSMA based protocols, it involves threshold approach, wherein it can have lots of false positive. But whereas in BMAC follows an outlier detection approach, where the node searches for outliers in the received signal through multiple signal strength measurements. So it so happens in SMAC that it makes use of carrier sense medium axis, and all these mechanisms are based on threshold values, but there is no consideration of the noise floor, thereby this might result in false positive. But whereas here in BMAC, an efficient way of CCA is done, that is clear channel assessment is done, that involves lot of complex mathematical equations in it. So here for signal detection, BMAC follows an outlier detection approach, where the node searches for outliers in the received signal through multiple signal strength measurements. BMAC CCA mechanism works as follows. Following a transmission, a node first takes a sample of the channel to update its noise floor estimate. Before transmitting any packets, it takes several samples of the channel to determine outliers. If an outlier is found, the channel is assumed to be clear and the packet will be sent. If no outlier is found, that is, if the channel energy associated with the channel is constant, the channel is determined to be busy, and back off mechanism will be used for that. The problem addressed by BMAC protocol in the context of CCA are success of low power listening technique, because it relies on accuracy in sensing the activity on the channel. Each node samples the network for short amount of time and goes back to sleep. So false positive. Precious energy is wasted if a node assesses that there is activity on the channel and wakes up when there is no activity. Detection failure. If a node cannot detect a preamble destined for itself, followed by idle when it is occupied. Transmitter inaccurately assesses that the channel is idle when it's being occupied, results in collision. So these are all the main problems that which are being addressed by BMAC protocol, that too in the context of CCA, clear channel assessment. And finally we have this qualitative evaluation of BMAC. So its pros are BMAC can be used as core MAC protocol on which other schemes can be built. Most of the false positives are eliminated by using this BMAC, and channel efficiency can be improved. Noise floor estimation mechanism enables the MAC protocol to adapt to its surrounding. And it is a simple lightweight protocol which requires small memory space, and it provides flexibility and interoperability for the development of higher layer protocols. Whereas there are associated disadvantages with BMAC, that is BMAC implements a simple CSMA based MAC protocol that where hidden terminal problem is not addressed. Underutilization of wireless channel in high density and high traffic networks. That is underutilization of wireless channel in high density and high traffic networks. If the traffic is high, then low power listening mechanism requires nodes to transmit long preambles, which creates significant overhead. To improve carrier sense, BMAC introduces additional complexity through the clear channel assessment mechanism. Multiple measurements are needed to be taken before the channel is determined to be clear. So these are all the disadvantages of BMAC. Then we have still more better protocol called as CC-MAC, that which is an abbreviation of correlation based collaborative MAC, and in our next video we will be going through that.